Alright, welcome back. In the chat, Arkham has been telling us about this thing called the microbit. Which looks like a cool little hardware device. It's got LEDs and buttons. Yeah, it looks cool. It looks fun to play around with. Alright. So, back to our project. We are building this sketch API to do simple processing like sketches. And we have the basics of it. It's rendering this line for us on the screen. But what we want to do next is have the scene renderer use random values. So we've set up a model to use an initial random seed. So first what we want to do is use the random seed when we render things. So I think we're going to have to pass this seed all the way down through render scene, which will pass it to the shape, which will need it, because basically anywhere we want to generate a float, we're going to need a seed. So actually, maybe we should start there at the lowest level of fix up this toFloat function to do what we need to do, and then see where we need to thread the seed through. And actually, this was kind of my intuition earlier when I said we were going to keep these toFloat and toColor functions private, as well as these render functions. We'll have even more reason for keeping them private in just a minute, because the types for these functions are going to get pretty messy as we start threading the seed through. But I feel like that is totally fine. We'll deal with all the mess in this module, and then anyone who uses it will just have a nice fun time without having to worry about threading random seeds through and destructuring tuples and all that good stuff. So here's what we want to change. Start our change from. Random numbers are currently generating constant values. We want to change this to instead just record the min and the max, and then we'll later generate the random number at render time when we actually have a seed. So to do that, we're going to define our new sketch number type, which will be a random, which will take two floats. Actually, I'm just going to use a record for this. Min and max. And we need to make this a record too. Min equals min, max equals max. A little more typing here, but it'll make it nicer to write code for when we access it. Okay, so our next error is our case in toFloat needs to handle these random numbers now. Random number, and this is the min and the max. Okay, so here we need to actually generate the random value. So what kind of generator do we have? We have a float, which returns values in the given range. Perfect. So we can make a generator for the float. So we'll use random.float with min and max. We'll have our generator now. Now we want to use the generator to create our float value. So we'll use random.step. Pass it the generator. I think we're going to need a let block here. So there's our generator. Then we're going to have value new seed equals random.step. We'll pass the generator and we'll pass the seed. And then we'll give back the new value. So we've got some problems here. So first of all, we don't have the seed. So let's add that to our type signature. And I feel like it's better to put it last because of the currying. The seed is going to be changing more often than the definition of the number will change. So I'm going to put the seed as the last parameter. And then we're going to need to give the new seed back so that our app doesn't keep generating the same values every time. So we need to give back a tuple with this. So in that case, actually, we can just spit this back out. And seed is here. All right, and then in this constant case, we're just going to give back the same seed because we didn't use it, so it's fine to save it for later. Okay, and then I actually am just going to inline this now that we're done. Okay, so now we should have problems everywhere that we're using toFloat because we changed the type signature. So here we're using it in toColor. So let's deal with that. So basically anywhere we're using toFloat, we need to pass a seed now, which means we need a seed, random.seed, and if we're using the seed, then that means we need to return a new seed. So that means we're going to need a let block in here for sure. And we're going to get the hue is going to equal this, and then we'll use the hue value in here. And then we need to turn this into a tuple and give the new seed back. Oh, and we need to actually call toFloat on all of these. So then we're going to have the saturation value, and seed 2 is going to equal toFloat of saturation and seed 1, then the lightness value, and seed 3 equals toFloat of the lightness with seed 2, and then the alpha value is also going to be the same thing. Alpha value seed 4 is going to be toFloat of alpha and seed 3, and then we return seed 4 in the end. And then these toFloats we don't need. Okay. So yeah, this function is getting to be a mess, but I'm not really worried about that because this doesn't depend on much other stuff. And the API we're ending up with is pretty nice. Yeah, at least FixPoint is mentioning, like Haskell in particular has language features to support doing a lot of this kind of stuff automatically. Yeah, I mean, it does add a lot of complexity to the language itself to have stuff like that, and it's not like it was hard for me to write this function, and also I'm not expecting to ever really need to come back and change this much anyway. So I don't know, there's trade-offs there. Okay, so here we're going to have the same thing. And actually, maybe there'd be an interesting way that we could refactor this to, rather than passing the seed all the way through, maybe we could just compose generators for colors. Actually, that might be an interesting refactoring to look at, but I'm not going to worry about it at the moment. That could probably save a lot of code here. Okay, but for now, let's thread our seed in manually. So we're going to do the same thing for our render shape. And actually, so I write Elm format, which is written in Haskell, and I've run into some things there where, okay, you can use monads for certain things, but then eventually you get to a point where you want to use multiple monads at the same time, and then you're in the same position where you have to go back and like refactor your entire code base and touch every place that you're using the monads. So Haskell makes certain things easier, but there are other things that you can run into that still can be problematic. Okay. So we're going to grab this, and we'll say width value seed1 equals toFloat with the seed. Height value seed2 equals toFloat of the height with the seed. And color value seed3 equals toFloat color seed. I messed these up. There we go. And then we're going to return seed3. Oh, and this is actually to color. Color. Gotcha. Then we take the height, width, height, and the color value. Okay. So we got that one. And then finally, render scene is going to do the same thing. Random.seed. And this returns also a tuple. And we'll have shape value seed1 equals render shape seed in, and then we will return this and the new seed. Oh, and we've already used render shape. There we go. Cool. Okay, so we've threaded the seed all the way through, down to values. And then, yeah, people are talking about generators and monad stacks and things in the chat. But yeah, in the meantime, I've finished writing the code that we needed to write, so onward. Okay. So our view now is rendering the scene. Interesting. So this is kind of an interesting thing. So render scene ends up giving us a new seed back. That's not really what we want. Huh. I guess, this feels a little bit hacky. What I'm going to do in the view is just throw away the new seed. And then in the update, we'll throw away the HTML. Seems a little funny, and maybe there's a better way to do it, but it should implement the API and make it work. So we're going to throw away the seed. Just return the HTML. And then we need the seed from the model. Okay, so I don't know if you can see what happened, but this square on the screen got lighter, or down there. So it looks like this may have worked. So now what we want to do is have our update get the new seed and process it, and also trigger the update every so often. So I want to define a message type first. Type scene message is new random value, or new random seed, and we'll say case message of new random seed. And if we get that, we're going to have a let block, and we're going to call render scene but throw away the HTML and keep the new seed. Sounds maybe wasteful, but I guess we'll see. Whoops. So maybe we need a way. Yeah, I'm not going to worry about optimizing it at the moment. I'm sure there's a way we could restructure the way we're dealing with the data here to make this more optimal. Okay, so then we're going to take our model and change the seed to be the new seed. So that should be our update function. So now we just need to trigger a new update every so often, maybe every 100 milliseconds. Let's try that. So that's in process.sleep, I think. Here we go. Process.sleep. So I'm just going to define this as generate next random seed. This is going to be a command of scene message, and this is going to equal process.sleep 100 milliseconds, which gives us a task, and then we use task.perform, and task.perform takes two functions. One that produces the error, one that produces the success. And in our case, we're going to generate this regardless of if there's an error or not. Actually, we know from the type that sleep can never fail. And then we get the task, and then we get the command back. Okay, now I guess we need to import process. And we need to import task. Okay. Function perform is expecting the first argument to be a function. Oh, I have a function in this module called always. So I need to use the one from the basics module. Okay. Let's see. AntennaB is asking, why use process.sleep instead of time.every? Good question. That is a good question. Why don't we do that? All right, so I'm going to comment that out and have our subscriptions. So time.every is a subscription, right? Yep. Okay. Time.every, that is a great idea. I guess if we wanted more control, I guess you can still start and stop subscriptions using the model. Yeah, I can't think of a reason why we should use sleep instead of every. Okay, so we'll use every 100 milliseconds, and then we'll say always new random seed. And now we need to import time. And and we have to use our basics.always. Okay, maybe always is not the best name. Hey, cool. And there we have our randomness. Awesome. Okay, so I think we should definitely commit this where we're at so far. And our next step, I think the next step I want to do is make it be able to rotate. And then after that, in my processing example here, it keeps the past things that were drawn on the screen, so you get this kind of build up over time. So I'd like to do that as well, and that can just be built into our sketch rendering. Excuse me. So let's go ahead and commit this. So what do we have here? We can put Elm stuff in the git ignore. We can also put node modules in the git ignore, and we can put index.html in the git ignore. Cool. So we have a working sketch API for drawing random rectangles. That's all we can do with it so far, but it's a good start. And then let me put this up on GitHub. Here's the repo, and it should be the same link that's in the bottom of the screen. Cool. So that's all up there. So if you want to grab that code, feel free to. All right. So next, what I'd like to do is add rotation in here. And in my original sketch, we had this base angle. So what's interesting here is that the base angle depends on other things, like the x coordinate. So that could end up being very problematic for this API that we're trying to build out, because we'll have to add a fair amount of complexity and maybe even like modeling of functions within our definition of values. Anyhow, let's just dive headfirst into this and see where we end up. But let's start by rotating a random amount. So this is 0.5. Is this in degrees or radians? I assume this is in radians. So let's rotate by a random amount of degrees. Or sorry, I guess radians. So here's what I am imagining the API would look like. Sketch.rotate. And then we'll give it a value, sketch.random. Somewhere between, well, let's do a minus 0.5 and 0.5. And then we need to define sketch.rotate. So I think this goes in the shapes section. This is going to take a sketch number, how much to rotate, and then it's going to take a shape and give back a new shape. So I think we're going to need to define a new shape type to do this. So this will be rotate. This will take a sketch number for the angle and a shape. All right. So then all we have to do is implement this. Sounds easy, right? So we'll have the angle and we'll have the shape. We're going to use a let block. We're going to have to turn the angle into an amount, or into a value. So we'll get our angle value and our new seed equals toFloat angle seed. Then I think there's a render.rotate. Let's look at this graphics render API. And all it does is take an angle and a form and give back a new form. So that's perfect. So we're going to rotate by the angle value. Then we're going to render shape. Okay, so we're going to need to process the seed again for that. So the shape value and seed2 is going to equal render shape with the shape. Let's call this the inner shape. Give it seed number 1. And then we should get back that. Okay, so then we're going to rotate this produced shape value that we have, and then also give back our seed2. Okay. So that all compiles. Oh no, it doesn't compile. Because we don't expose rotate. Okay, so let's start putting these in order. So we have scene first, then we have rectangle, then we have rotate. Hey, and there we go. We have our randomly rotated line. That looks good. So actually I'm going to go ahead and commit this. So we just added a new way to transform shapes, implemented that by adding a new private constructor tag to our shape data type, and then just implemented the one place that we destructure that shape data type. Cool. That worked really well. Okay. So the next big feature I want is for us to keep the old values. So what's the best way to do this? This could get really performance heavy. So we could just keep a list of all of our past seeds. We could also maybe just keep a cache of all the past HTMLs in the model. That doesn't sound like the nicest thing, but it might be the fastest. Or basically, what we want to keep track of is, like, we're always going to have one background. Let's see, where's our render? So when we go to render scene, we have our background, and then we have this shape. What we want to do is keep a list of shapes and render them all. And basically, we'll just be adding a new one every time. So maybe we should try this. Instead of our seed, let's make our seed be a list of random seed. We'll store the list of seeds in the model, and then we'll render all the seeds every time. And if that gets slow, we can try using HTML lazy or something, although that might have some big memory implications. In any case, I'm trying to recreate the nice experience of writing processing sketches, not necessarily the performance of it for today. So let's try this. We'll store our seeds. So in our initial model, we'll start with an empty list, which will actually be nice. So it'll start with just the blank background. Then every time we get a new seed, we will add that to our list of seeds. And then our model here. So now when we render scenes, I guess what we really want to do is take the list of seeds here. Oh, interesting. So we don't want to render the whole seed. All right, my brain's kind of jumping ahead here. So because we're given a list of seeds, we don't really want to produce a new seed when we render the scene. So that means this can all go away. That also means then that the update to calculate a new seed can just directly call the render shape. And actually we have the shape right here. Okay, so then we don't need all these extra parameters. Cool, and that code actually looks cleaner. So then here we get a list of seeds that we want to render. So in that case, we're going to take our seeds and list.map, and for each seed, we want to render the shape with this seed. And this is great. We don't need this let anymore because we don't need to return a changed seed. The view function is never going to modify things. It's only going to render. So we get that, and then actually we want to destructure that, so we'll take the first value from this tuple that's produced. Oh, we can use a normal pipe. Okay, so then we get a list of forms, and then we can just stick those in a group. Okay, so that function's good. Now this one is not good. So what's going on? It's expecting the argument, it's expecting update to take something. Okay, looks like we're still referring to seed somewhere. Okay, this should be model.seeds. Actually, we want to get the first seed. If that makes sense. We can only do this if we have an existing seed, right? We want to render shape with a current seed, but we may not have one, is the problem. Okay. So current seed equals, and we will do a case of model.seeds of, and if we have an empty list, then we'll use random.initial seed 0, and if we have a first value, then we will use that first seed. Okay, so what is the error here? The pattern match doesn't work. Case model.seeds. This is on line 66, yep, which is here. Model.seeds should be a list of random seeds. Oh, the pattern matches things of type random.seed. No, it doesn't. Okay, let's just put this in temporarily. Okay, so then what's wrong down here? It's expecting the right argument to be a list of random seeds Okay, that works. Then new seed from render shape gives us back one new seed. So we get the new seed there. Let's see. So we should be able to add that to the list, right? Am I doing my list concatenation backwards? That should be right. If I have one and add it to an empty list, that gives me a new list. Okay, so what am I not understanding in this message? The right argument, it's expecting the right argument to be a list of random.seed. And it should be. Okay, so what's wrong with our update? This should be a scene message and a scene model, and give back a scene model and a command of scene message. We call this scene state. Model.seeds, why does it think it's a, oh, it's because of this. Here we go. So we need to use the current seed here. Got it. Cool. And that is an error message that is supposedly fixed or improved in the next version of Elm. Okay, so now let's try to do this switch that we were trying to do before. Hey, there we go. Okay, so it looks like that's rendering all right, and it's probably going to have some performance problems. Alright, looks like people are having trouble with the video stream, so I'm going to just reset that real quick. All right. So hopefully that restarts. So we seem to have this working. I'm a little worried this is going to just consume memory and crash my browser or make this go slower somehow, or make my computer go slow. But it does seem to be doing what we want. What we want to do next then is add in a sketch.move, I guess. And we'll have x and y coordinates. So let's go from like -50 to 50. And the same for the y. And then we need to implement a sketch.move. So I'll add it up here first. And we'll have move down here, just like we had rotate. This one's going to take 2 sketch numbers. All right. Yeah, looks like the stream is coming back for people. Good. Yeah, I'm not sure what happened. My chat client, too, said that the stream was offline for a minute. But it looked like it was uploading continuously from here. So now we're going to have move. It'll take an x and a y that are sketch numbers, and a shape, and give back a new shape. And we'll just save this for now. XY shape. Create the new shape type. And then we'll need to implement that. So this will be similar to rotate. And we'll have x, y, and an inner shape. We're going to get our x value from x. We're going to get our y value and our seed2 from toFloat with y. And then we'll get seed3 from the shape. And then, what is our function? Here it's even called move. Great. And then we have our x value and our y value. All right, so I did something wrong here. The second branch gives a tuple of form and seed, and the third branch gives, oh, I put a comma in there accidentally. Cool. Okay, so now we're rendering on there. I'm going to put the width of these lines to be smaller and increase the width and height of the randomness. And it looks like it's using the same x and y value all the time, so yes, I'm using the wrong seed for the y value generation. There we go. Cool. So I'm going to go ahead and commit this as well. So we showed sketch renders previous shapes and implemented sketch.move. Cool. So to recap, we've been working towards recreating this processing sketch that I wrote a long time ago. And not only creating the sketch, but also trying to build an Elm package that makes building this sort of thing easy to do. So you can see down under my video where we're at so far. And here's what our main program looks like. We define a sketch with a background color, a shape, and then we can define random properties for the width, height, color, and transformation. And then we've been building out this sketch library that implements that and basically takes a scene definition and generates a program that randomly runs itself. So let's see. What I want to look at real quick is these colors. So I think this is one problem in the color. This is the lightness. Let's try to bring that down a bit. Oh, yeah. Okay, so here's one reason why things look so different. So in processing, it uses hue, saturation, brightness, and Elm uses hue, saturation, lightness. And I'm not sure if there's a good comparison image. Yeah, here we go. So we're using this HSL world in Elm, where as the lightness gets higher, the most saturated colors are in the center at lightness 0.5, and if you go to 1.0, you get white. Whereas with HSV or HSB, which is what processing used, it uses this model on the right, whereas you go to the top, you get more colorful unless your saturation is 0. So that is why the colors look so different on here. So I'm not too worried about, we could easily implement that algorithm to convert between the two. So I'd like to work more on the randomness for today then. But maybe what we can change in here is to change the lightness values to be in a tighter range, more around the colorful area. And we can do the same thing here. Yeah, okay, so the colors are a bit different, but at least we understand why. Alright, so our next challenge is maybe even going to run up to a problem that we can't actually solve with the way we've been designing this library so far. So basically what we want is for the angle that we're rotating to depend on the X position that we've chosen. So currently we have, let's see, so how can we design an API for this? So here's our rotation here, and here is our X position. So I guess what we would like is to call this x and be able to define x as a variable, which works. But then we want to have rotate be able to depend on that. So we want to have the base angle, and actually in this case it uses the base angle plus another random amount. So let's hold off on this extra random amount and try to just calculate this base angle based on x. So if we have this, what we want to take is the sine of 10 times x, and our width is just 500 at the moment. And then then take the sine of that and divide it by 3. The problem here is that x is not a number. So what we want is maybe something like a sketch.calculate based off of our x, and then give it a lambda function or something. And call this v. Maybe we could define something like that, where we can take, excuse me, we can take a sketch number and then build off of it. Actually, we already have a separate problem here, which is that if we reuse this x, let me comment this out for a moment. And I need that turned back on for a moment. Okay. So we pulled this variable out, x, but if we use x twice, it actually will give us different random numbers each time. So that's an interesting problem with this API as we've defined it. Because we're basically declaring a random value, but that value doesn't have an identity. It's just a way to generate numbers. So that doesn't let us define or refer to anything that we've previously defined. Yeah, okay. So that's the problem. Let's take a short break, because it's been almost another hour, and think about that problem a little bit. I'm not sure that we'll actually be able to get this to work, given this kind of API that we're designing. But maybe we can come up with some clever way to deal with it. So let's think about that for a few minutes, and we'll take a quick break, and I'll see you back shortly.